welcome back. For decades, astronomers had a very specific baby book for universe. According to our best model, the early universe was supposed to be messy, chaotic place. We expected the first galaxy born just a few hundred million years after the Big Bang to look like a toddler, small and disorganized clump of hydrogen and helium, and just barely beginning to find their shape. So, but then we sent a giant golden mirror into deep space. The James Webb Space Telescope was designed to see the first light. But when the data started trickling in, and it didn't show us a nursery of toddlers, instead, it showed us the teenagers and galaxies that are already big and already structured and chemically mature, exhibiting traits we thought took billions of years to develop. So today we are talking about cosmic growth spurt, and why does the early universe look so old? How does this discovery fundamentally break our understanding of how everything began? So to understand why these new galaxies are so shocking, and we have to look at what we thought we knew. And this is a standard model of cosmology. So after the Big Bang, 13.8 billion years ago, the universe was hot, dense soup, and as it cooled, the first atom formed, mostly hydrogen and little helium. For a longer time, there was nothing else, and no light, no stars. We call this a cosmic dark age. So eventually gravity did its thing, and it pulled those gas clouds together to ignite the first stars. But here is the key. The building a mature galaxy like our Milky Way is supposed to be slow, hierarchical process. And in this old model, small clumps of star merge to a bigger clumps, and those clumps merge to become dwarf galaxies. So over billions of years, they settle into the beautiful rotating spiral we see today. Most importantly, the chemistry of the galaxy was thought to be slow burn. So you start with just a hydrogen. You need generations of stars to live, die, and explode as supernova and to seed, and the universe with heavier elements like oxygen, nitrogen, iron, and this is a process that takes time the early universe simply didn't have. So now enters the JWST, because light takes time to travel. Looking deeper into the space is literally looking back in time. And when JWST look at these tiny red specks, it's seeing them as they were just 500 to 700 million years after Big Bang. So to put all this into the perspective, if the history of the universe was 24-hour day, we are looking at the universe at about 5 a.m. So astronomers recently analyzed a group of these early galaxies, found something that shouldn't be there. So they are expected to see the pristine gas, pure hydrogen. Instead, they found oxygen, neon, and carbon. So in astronomy, we call this metallicity, and these galaxies were rich in it, and they weren't just messy blobs, they were teenager galaxies, and they had already gone through several life cycle of the stars, and they were actually growing up in a fast forward. It's like meeting a 2-year-old with already has a driver license, and at 401k. So it is just doesn't fit in the timeline. So this creates a massive problem for physicists, and let's look at the math now. So, and also try to understand what is the problem. To get the amount of oxygen JWST is seeing, you need a massive star to form, burn through their fuel and explode. Then that enriched the gas needs to cool down and form a new star. So in our old model, this chemical enrichment was like a marathon. JWST is actually telling us it was a sprint. Now this leads to two possibilities or two possible options, equally mind-bending conclusion. So option one, let's discuss that. So option one says that stars in the early universe were much more efficient at creating heavy element that we thought. Maybe the first star were massive monster that lived and died in the blink of eye. Now the second option is where the galaxy started forming much earlier than we ever imagined, potentially even during the dark ages, and where we thought nothing was happening, nothing was possible maybe. So if option second is true, then we have to rethink the very first movement after the Big Bang and what was pulling that gas together so fast. So there another player in the cosmic growth spurt, that is supermassive black holes. Usually we think of a black hole as kind of galaxy killers or maybe late stage inhabitants, but JWST is finding massive black hole at the center of teenager galaxies. So some scientists now suggest that black hole didn't come after the galaxies. They might have been the seed that started them. So instead of gas slowly clumping together, these primordial black holes might have acted like a cosmic vacuum cleaner and sucking in a massive amount of gas and triggering the star formation at the rate that defies our current physics. So this would explain the old look of these young galaxies. They didn't grow up. They were forced to mature by gravitational power of these early giants. So what does this mean for us? So it means that we are living through a Copernican movement in the astronomy. For the first time, indicates the textbook are being rewritten in the real time. We are discovering that the universe was far more active and far more organized and far more mature in its infancy than we ever dared to dream. So the universe growth spurt isn't just a weird data point. It is a clue. It tells us that ingredients of life thing like oxygen and carbon were present in the cosmos much earlier than we thought. So the stage of everything was set almost immediately after the Saturn rose. As we go further and we continue understanding the JWST and that also giving the information into the void, one thing is definitely very clear. The early universe wasn't a quiet nursery. It was a roaring, high-speed engine of creation. So this is something new we were discussed. Thanks for watching. We want you to keep up with how JWST is breaking our brain every single week. So make sure to hit that subscription button. See you in next one. Bye. Take care.